at you. All right, so today we are naming and identifying parent functions, particularly polynomials. So we're gonna start with like where we're at. So remember, you don't need to write this green part down. We're just gonna talk about it. So over your math career, we started learning a lot about graphs, right? So we learned about like coordinate points. So like if I have a point like this, like maybe that's 3, 2, right? Coordinate points, probably started with that in like when you were little, right? And then you learned like there were points, you could put points in a line. And when you made that straight line, when you connected those points, you had a straight line, and that was called linear. You've already done that. There's even the word line in it, linear. Okay. And then this year, and maybe a little in 9th grade, we talked about quadratics, right? Quadratics, those parabolas that look like this, right? Quadratics. Just like that. And so you have learned like all the way from points to lines to curving lines. And now we're going to start talking about polynomials, right? And polynomials are just like more curving lines. They curve in different ways. Pretty cool. So let's start with a couple, just 2 words for vocab. The first word is polynomial, right? Polynomials. So you are writing this down. Write the word down, polynomial. And we're going to break it down. Poly means many. Poly means many. And nomial means terms. Many terms. So this word literally means many terms. It just means we're going to take some terms and put them together, right? And terms can be things like x squared or 3x or 9. All of those things are terms. That's 3 different terms. And polynomials are when we add or subtract them together. So you've been dealing with polynomials already, right? So polynomials are many terms. All right. And then we have the degree. The degree is the biggest exponent. The biggest exponent. So if I have something like x squared plus x to the 4th minus 10x to the 3rd, if I have something like that, the degree is the biggest exponent. So here's our exponents. Our exponents are those little baby numbers, right? So we have exponent 2, exponent 4, exponent 3. What's the biggest exponent? Which of these is the biggest exponent? You can put it in the chat. You can come off mute. Either way. What's the biggest exponent? Yeah, for sure, Alexia, 4, right? For sure, for sure. Right, so 4 is the biggest exponent. So we'd say the degree of this is 4. The degree of it is 4, the biggest exponent. You might be thinking, but wait, what about the 10? The 10 is called a coefficient. It's not an exponent. It's not a little baby number. It's a number in front. So that one doesn't count. Only the exponents count. This is note 34. Yes, yeah. Yep. All right. So we have 2 words for vocab, polynomial and degree. And now we're going to talk about how polynomials are named, right? So remember from our title, we're talking about naming polynomials today, right? So polynomials are just like us, right? They're just like us. They have first names and they have last names. So their first name is about the shape, right? Their first name is about how they look. And their last name is about their size, how big they are. So they have shape and size. All right. So let's talk first about first names. All right, so the degree, the biggest exponent, tells us what the shape of the line is. So if the degree is 0, yeah, Mia, you're gonna write this down. You're gonna write down this 0. You're gonna write down the word that I put right here. You're gonna write down this graph, just like this. You don't need to have these ones up here. Thank you for asking that clarifying question. So when the degree is 0, that means that we're just dealing with a number, just any number, 18, 35, 27, -4, right? Any number. When we just have the number, the first name, it's called a constant. It's called a constant. And the graph just looks like a flat line. Just looks like a flat line like that. This is like y equals 2. The negative graph, like y equals -2, just goes on the bottom, but it's still a flat line. The negative graph just goes on the bottom. Right, so we have then, if it's just a number like y equals 2, it's constant and it's flat. So we probably learned about these first, like in Algebra 1, we learned about graphing these. Maybe in 8th grade, we learned about graphing, right? And then we started to say like, okay, if we have a degree of x, right? If our degree is 1, if that's our biggest exponent, like y equals mx plus b, right? These are our linear lines. These are our linear lines. And this is like the graph like this. Y equals x. Does anyone remember what happened when we had y equals -x? Or does anyone have a guess of what happens to the line? With y equals +x, the graph is going up. What happens when we had y equals -x? What happened when the graph was negative? Yeah, right, it goes down. Yeah, it goes down like this. It goes down. So when we had our linear lines, they created straight lines like this. And if it's positive, it's going up. If it's negative, it's going down. Awesome. Can you pop an R in the chat if you are like caught up on the notes? I just don't want to go too fast. Thanks, Emily, for letting me know. Thanks, Ezra. Still a little bit since we're not quite there. All right. Okay, so then after we started working with like y equals mx plus b, we started talking about x squared with our degree of 2, right? Degree of 2. Does anyone remember the word that goes with x squared? It starts with a Q. Starts with a Q. There was like a fancy word. It's actually over here in this green box. Does anyone know the word? Or what do we call x squared? Quadratic. Yeah, absolutely. It's called quadratic. Quadratic, like that. And with quadratic lines, right? With quadratic lines, when it's x squared, the line makes like a parabola, like this. And when it's positive, it ends going up. When it's negative x squared, it ends going down. Right? So when it's positive, it goes up. When it's negative, it goes down. Right? So positive x squared and negative x squared. Awesome. So these are the ones that we've learned so far: constant, linear, and quadratic. We've talked about these for many, many days, many, many moons in class. Today, we're going to jump into even higher degree functions. So we're just going to learn the shape of them today. So with x to the 3rd power, right? What's another way I could say x to the 3rd power? X what? This one is x squared. X to the second power is x squared. Yeah, x to the third power is x cubed, right? X cubed. The name of this function is cubic. Cubic. Turn to your dog and say cubic. Cubic. Cool. So when we have positive x cubed, right? Positive x cubed, we have to end going up, right? We have to end going up like this because it's positive. And it kind of looks like this. Kind of looks like that. It has like three sort of parts. It has up one, down one, up one, three separate parts. Some of them are kind of flat, like the true x to the third looks like this, right? But it has that three parts, 1, 2, 3, right? So when it's positive, it's going up. What happens, what can you guess is gonna happen if I have -3? Is it gonna go up or is it gonna go down? Negative x to the third. Down, yeah, for sure. It's gonna end going down. It's gonna be 1, 2, 3, something like that. Right, so we have 1, 2, 3. It's not really like pointy, they should be rounded. You don't want it to get too pointy, but it looks like this. And they can be anywhere on the graph. It can be like way over here, it could be like way up here, it can be like way all the way around like that. It can be everywhere. But we'll just draw this one like this. So those are our cubics. 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 All right. For the next one, so this one was like x cubed, right? X cubed. For x to the fourth power, there's not really a name for it, right? But let me ask you this. What coin there's 4 of them and they make up $1? What coin, like pennies, nickels? There's 4 of them to make up $1. What kind of coin is that? Four of these things make $1. Yeah, thanks, Alexia. Quarters, right? So 4 quarters or 4 quarts make a gallon. The prefix is quart, and this is called a quartic. Quartic. Turn to your baby sister and say quartic. What if you started teaching your baby sister how to speak and her first word was quartic? That'd be cool. Quartic. If we were in class, you'd hear everybody. Quartic, quartic, quartic. It sounds like a weird word. Quartic. Okay, so quartic, x to the fourth, have 4 parts. Right? They have 4 parts, and they look like this. So this one has to be ending up because it's positive. So we have like 1, 2, 3, 4. Kind of looks like a W. Right, so you have down 1, up 1, down 1, up 1. That is 4. What kind of looks like a W. They don't have to look like this. They could also look like this, like more like even. They can also be like really uneven, like this. They can be really skinny, like that. They can actually be really flat. They can look like this, too, right? But they have 4 basic parts. 4 basic parts. Something like that. So when we have a negative x to the fourth, right? Negative x to the fourth, it has to end going down, right? Has to end going down. So I might have something that looks like this. Looks like an M. Looks like an M. Kind of like my name. M. Miss Macmillan. I got 3 M's in my name. All right, so we have quadratic with 2 parts, cubic with 3 parts, quartic with 1, 2, 3, 4 parts, right? And then the last one is x to the 5th, x to the 5th. Okay, the only word I can think of that uses this prefix is The word for when you have 5 babies at the same time. So you have 2 babies is twins, 3 babies is triplets, 4 babies is quadruplets. Does anyone know the word for 5 babies at the same time? 5? It's a weird word. Quin something, yes, Ezra, exactly, quintuplets. Quintuplets. So it's quintic. Quintic. Good job, Ez. Quintic. All right. Positive x to the 5th. Does it have to end going up or down if it's positive? Should I go up? Yeah, it goes up. Goes up at the end like this. It has how many parts if it's x to the 5th? X to the 5th has, 5 parts. So we have 1, 2, 3, 4, 5. Something like that. Ooh, kind of looks like a straight line, right? Kind of looks like a linear line. It just has some like funky stuff happen in the middle, right? So 1, 2, 3, 4, 5. So it's going up. And then negative x to the 5th. Which direction is it going? Yeah, it's going down. Good job, going down. So we have 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. Just like that. And again, they can be flat. They don't have to look like this. They could be like 1, 2, 3, 4, 5. They can look like that. But I'm exaggerating the like ups and downs so that we can really understand that it has like 5 parts. 1, 2, 3, 4, 5. Just like that. Awesome. And then like we kind of give up on fancy names after that. So like x to the 6th, right? X to the 6th, we just call this a 6th degree polynomial or 6th degree. And then if we had something like x to the 10th, it would be the 10th degree. If we have x to the 30th, we'd have the 30th degree. If we had x to the 100, we'd have the 100th degree. So we stopped giving them like fancy names after that. For sure. So we're learning some new words: cubic, quartic, quintic. Ooh, say that 5 times fast. Cubic, quartic, quintic. Cubic, quartic, quintic. Cubic, quartic, quintic. Ooh, that's hard. Cubic, quartic, and quintic. All right. So those are their first names. Their first names are based off of their degree, right? Based off of their highest exponent, right? Those are their basic, their first names. Their first names. They also have last names, right? They also have last names, and last names are a little bit easier. Their last names are just based on how long the question is, right? Or how long the expression is. So in this one here, it's based on the number of terms. So see how, you don't remember, you don't have to write this, it's in green, but see how the number of terms is 1. There's just 1 term here, right? In this one, there are 2 terms. This is 1 term and this is 1 term. It's how many things are being added or subtracted, right? Remember in our first one, we had 1, 2, 3. 1, 2, 3, that's 3 terms. And then if we have 4 or more, it's like 1, 2, 3, 4, or even more if there were more. Okay. So if there's only 1 term, right? There's only 1 term. The word is monomial. Monomial. So monomial. Monomial. I can't really think of anything except for like if you get mono, you have to stay by yourself. Like you can't hang out. I don't know. Monomial means 1. And then all of these end in nomial. All of them end in nomial. We just have to figure out what they start with based on the word. Okay, so let me ask you this. So 2, if the thing that I'm writing, right, if I'm writing this thing and it has 2 wheels, what do you think I'm writing? It doesn't have a motor. What am I writing? A bike, yeah, a bicycle, right? Or if I am bisexual, I like 2 sexes, right? Bi means 2. So when we put binomial, it means 2 terms. 2 terms, it has 2 parts, like bisexual or bicycle. For 3, does anyone know the prefix for 3? Like if I have a bike, yeah, a bike, but it has 3 wheels, it's called a tricycle. Absolutely, Emily. Or like if I'm a triathlete, I do 3 sports, right? So 3 parts would be called a trinomial. This over here is a trinomial. And then for 4 or more, you might be thinking maybe like quad, but quad means 4, but unfortunately that's not it. It's 4 or more. If we're talking about many, does anybody remember from the very beginning, what is the prefix that means many? It's the name of this whole thing. Poly, yeah. So anything more than 4 or 3 or 4 or more. So there are special names for monomials, binomials, and trinomials, but after that, everything else is just a polynomial because it means many. Awesome. Okay, for this next part, remember that it's in green, right? It's in green here. So well, my computer's lagging. Hold on. There we go. So it's in green. You don't need to write this down. You can just get ready to chat and help me out. All right, get ready to chat. Keep your brain on. Okay, so for the first name, I'm looking at the degree, the biggest exponent. And for the last name, I'm looking at how many terms it has, how many pieces there are. So for this first one, I would call it a quartic polynomial because it's quartic because its biggest exponent is 4, right? If I look at all the exponents, the biggest one is 4. So it's quartic. Remember, x to the 4th. Wow, I really can't move this thing. There we go. X to the 4th is quartic, right? So if x to the 4th is quartic, then waiting for it to catch up. There we go. So we have 1, 2, 3, 4 pieces. So those 4 pieces, that makes me 4 terms polynomial. Right. So first we look at the exponent, and then we look at the pieces, polynomial. Okay. Awesome. Okay, so let's think about this one. What is the biggest exponent? What's the degree from 11 minus x? What's the degree? What's the biggest exponent here? It's kind of funky. There's an x here, but the x is all by itself. So the x to the 1, right? So I'm looking back at my chart over here, and I'm thinking, okay, x to the 1, that's linear. That's linear. X to the 1 is linear. Right? And then it has 2 terms, 1 term here and 1 term here. So what kind of nomial is it? Is it a monomial, binomial, trinomial, or polynomial that has 2 parts? What kind of nomial is it? Yeah, it's a binomial. Binomial, great job. All right, so a linear binomial. Nope, David, remember this is in green, so you're just helping me out. You're typing when you know the answer. It's in green, so you don't have to write it in your notes. So don't forget, you're not writing this down. He's just helping me. Yeah, no problem. So David, since you're not writing it down, when you have x squared, when I look at this one, I have x squared, x, and a number. When I have x squared, what's the first name that goes with x squared? Looking back at your notes. What's the first name? And it looks like this. Mono is from up here when we have one piece, right? When we have one piece. But when we have x squared, what's the word that goes with it? Yeah, Gracia. X squared goes with quadratic. X squared goes with quadratic. So over here, I'm going to have quadratic. No, I'm talking about, it's always the biggest exponent. It's okay, David. It's always the biggest exponent. So since the biggest exponent here is x squared, then we would have quadratic. Okay, and then how many pieces? How many pieces does it have? 1, 2, 3. So the last name that goes with three pieces is trinomial. Absolutely, Gracia. Good job. Trinomial. All right. The last one, let's try this one together. We have 19, right? We have 19. It is constant. It's just a number by itself. Remember, we have a number by itself is constant. We'd have constant. And then there's only one thing here. There's only one thing. So is it a monomial, binomial, trinomial, or poly? Yeah, monomial. It's just one thing. Monomial. Just like that. So this this number 19 is a constant monomial. So each of these terms is a monomial, and we add them together and make a polynomial. All right, that's pretty cool. Okay, so graphs, equations, expressions, technically. Expressions have first names from their shape and last names from their from how long they are, right? By how many pieces there are. So for today, for your assignment, you already have your notes here. For your assignment today, you have a few questions to go through. You have basically what you're going to do is you're going to look at this expression here, and then you're going to say, okay, what's the biggest exponent? The biggest exponent here is 4, right? So they put a 4 there, and that means that it's quartic. That means that's what its first name is, quartic. Looking back in my notes, I know that x to the 4th is quartic, right? And then, okay, the number of terms, 1, 2, 3, 4. I have 4 terms here, right? I know that when there's 4 terms, their last name is poly, because poly means many, polynomial. And then we write polynomial right here. So when I'm thinking about number 1, I'm thinking, okay, I have my degree, my biggest exponent. What's my biggest exponent in this question in number 1? What's my biggest exponent? Two, absolutely, Mia Q. 2 is my biggest exponent. I have x squared, I have x to the 1, and then I have no x here, so that one doesn't matter. So x squared is my biggest one, so I'm going to put a 2 here. So what does that mean its first name is? If I have x squared, I'm going to scroll back and look at my notes. I have x squared is quadratic. So I'm going to go here, say, okay, I'm going to type in quadratic right here. All right, awesome. And then how many terms, the number of terms, how many terms does this have? 1, 2, 3. So I'm gonna put a 3 right here. What kind of nomial does this make it? 3 parts, just like a 3-wheeled Bike is a tricycle. We would have a trinomial. So we'd say this is a quadratic trinomial. All right. So you're going to finish, if you are on track 1 through 4, so you're just going to finish these ones. If you're 1 through 5, you're just going to make one additional one up. If you need any help, there is a video launched there, attached there. And then the second part, instead of a checkpoint today, you do have an IXL. And I know you're like, Miss, IXL, what? 1, I can give you your password if you need it. And 2, you're going to a very low score. So you're not going to your normal 75 or 90. You're only going to 60 or 64, depending. And I'll also say this, if you work for more than 20 minutes, just screenshot it and turn it in, okay? If you're working for more than 20 minutes and you're just not getting it, I don't want you to like keep trying and trying and trying. So if you work for more than 20 minutes, you're done, no worries, you can turn it in. There is a video to help you on that exact IXL if you need it, it's right here. Okay? That is it. There is extra credit. If you want to keep going, you can get extra credit if you want, but it is just this part here where you're typing and then your IXL here. And that will get you all of your points, okay? I'm gonna go ahead and put you all in a breakout room so that you can continue to work with Miss Yama so that you can get it done. Your goal is to stay in the breakout room until you finish, right? If you have any questions, you can ask Miss Yama. If you just need some accountability, you can also ask Miss Yama as well. You have to do both parts. You do have to do both parts. Todos. Parte 1 y parte 2. Sí. Yeah, but no checkpoint. There's no Google form. So solo en amarillo, the yellow parts, is what you need to do. Yep. All right. Let me go ahead and open up these rooms. I'm going to open up those rooms and I will see you all on Thursday. Go ahead and head into that breakout room. See you on Thursday, friends. That was good, Mia? Good. I'm glad to hear it. Like you feel like you understand it? Yay.